So welcome back to chapter 3. We're going to look at objective 2 now. So we're going to use the same investment data that we used in objective 1. So I just left that up here at the beginning. So chapter 2, or excuse me, objective 2 is looking at percentiles and box plots. So we're familiar with percentiles. If you've taken a test, the SAT, the ACT, if your kid if you have a child in school and they take the STAR test or something like that, when you get those results, it tells you the percentile that you or your child scored in. So the percentile is how far from zero, let's say, that you scored or how well you did. So if you scored in the 87th percentile, then that would mean you did 87%, or you did better than 87% of the population. So there would be 13% of the population that scored better than you, and you scored better than 87% of the population. So this is a good way to measure kind of where we are, not just our own personal test scores, but if we're looking at data or we're looking at some sort of performance, we can measure how this performance is kind of against everybody else. Now, when we're looking at the percentiles, the median, remember the median is the middle value, the median is always the 50th percentile. All right, so if we want to construct a box plot, first of all, we need to construct the percentiles. This is really what we're getting at. So to construct what we're calling the pth percentile, this is any percentile you choose. It can be the 13th percentile or the 25th percentile or the 87th percentile. First thing we want to do is arrange the data in ascending order. Remember, ascending order means smallest to largest. Descending order is largest to smallest. So arrange it from smallest to largest. Then we want to calculate the position of the percentile by using this formula, where P is our desired percentile. So L is the location. So let's say that we're going to calculate the 25th percentile. You can calculate percentiles for anything you want, but the 25th, the 50th, and the 75th are the really important ones. In fact, those are so important we call them quartiles because they are the percentiles on the quarters. So they're obviously pretty important. So let's just calculate it for the 25th percentile. So we would say L 25 over here to indicate we're looking for the location of the 25th percentile. And if we're using our data that we have before of our growth data there, and hopefully maybe you've got your book open that has that data in the front, or you've got your spreadsheet, your worksheet open that has that data. Remember, there were 10 observations. The sample size was 10, so 10 plus 1. And then this is multiplied by 25 over 100, right? So just to go ahead and solve this out, 10 plus 1 is obviously 11, and I'm going to multiply that by 25 divided by 100, which is 0.25, and I'm going to grab my handy dandy calculator here. So 11 times 0.25 gives me 2.75. So that's the location of the 25th percentile. We're going to learn how to find that location on the next slide. So here we have our data again, and this is printed out for us. And notice for the 25th percentile, which we've already calculated there, it is 2.75. So this means that it is 75% of the way between the second and third observation. Okay. So let's also go ahead while we're here and calculate the 75th percentile. We already know what the median is. We calculated that in the first video, so that's the 50th percentile. But let's go ahead and calculate the 75th percentile. So what I would encourage you to do is pause the video now. You try calculating the 75th percentile, and then restart the video and check your answer. All right, so hopefully you've calculated this. So we're going to plug in 75 where we had the 25 plugged in. So we get 11 times 0.75 and we get 8.25. So that means that the 75th percentile falls 25% of the way between the 8th and 9th observation. All right. So once we know the location, if we happen to get an integer or a whole number as our location, so if the answer just came out to be 3, then we could say this observation, this is the 25th percentile. But of course, that didn't happen for either our 25th or our 75th percentile. So instead, we have to calculate that distance between the two observations. So remember, the 25th percentile was at location 2.75, so that was 75% of the way between the second and third observation. And then the 75th percentile was 8.25, so that's 25% of the way between the 8th and 9th observation. So for example, so we have already talked about this. So we're going to take our second observation. So if you're looking at your data, observation 2 is 1.71. Observation 3 is 3.17. So we need to calculate 75% of the way between observation 2 and observation 3. So 3.17, I'm just going to write this above it. This was observation 3. And this is observation 2. So first we're going to calculate the distance between observation 3 and 2. So 3.17 minus 1.71 gives me 1.46. So 75% of the way between those two observations is 1.095 or 1.10 if we're going to round to just 2 decimals. So then we have to add the second observation because it's the second observation plus 75% more. So that's where the 1.71 comes in. So the 1.71, remember, is observation 2, and this is 75% of the way between 2 and 3. So that means our first quartile, or the 25th percentile, is at 2.81. So why don't you go ahead and try to do the 75th percentile, find the location, pause the video, and then come back and check your answer. All right, so our 8th observation was 16.96, and we need the distance between our our 9th and 8th observation. So observation 9 is this 32.16, and observation 8 was that 16.96. So the difference between those two, 32.16 minus 16.96, gives us 15.2. And we're going to multiply that by 0.25. So when we multiply that by 0.25, that's where we get the 3.8. So we're going to take observation 8 and add to it the 25%, the distance between the 8th and 9th percentile, and that's how we get 20.76. So percentile 25 or quartile 1 is 2.81. And percentile 75 or quartile 3 is 20.76. So now we can use this to construct what we call a box plot, and that's just a visual representation of what's called the interquartile range. So the interquartile range is quartile 1, 25%, through 75%. It helps us also to identify if the data is skewed, which we can use a histogram for that, but it also helps us identify if there are any outliers. So this is a great way to determine if there are any outliers that we need to then investigate or deal with. So first of all, you are going to draw a box. So the box goes from quartile 1 to quartile 3. In other words, the 25th percentile, the 25th percentile and the 75th percentile. And this horizontal line, this vertical line, pardon me, right here is the median, or quartile 2, 50th percentile, the median. Now, we draw these whiskers out to the side. The whiskers help us to determine if there are outliers. So we're going to look on the next page of how to calculate the whiskers, but just know that the whiskers help us determine if there are any outliers. So if there are any observations that lie outside of the whiskers, like these do, then we would identify those as outliers. So when we construct the box plot, we have the minimum marked. So this is the smallest observation. We're going to have the maximum marked. That's the largest observation. We have the quartile 1, or the 25th percentile. We have the median, which is the quartile 2, or the 50th percentile. And then we have the quartile 3, or the 75th percentile marked. So the next thing I'm going to do rather is to try to determine if there are any outliers. So the first thing I want to do to determine if they are outliers is to calculate that interquartile range. And remember, I said earlier that the interquartile range is quartile 3 minus quartile 1. So if you look back in your data, you should show that quartile 3 was 20.76 and quartile 1 was 2.81. So that means the interquartile range is 17.95, I believe. Yep, 17.95. So when we look back at that box plot that we looked at earlier, and we're going to look at on the next slide, the left side of the box will be labeled 2.81. And the right side of the box will be labeled 20.76, and then the distance between how long the box is 17.95. So to determine if there are any outliers, we want to multiply this interquartile range by 1.5. So when we multiply that by 1.5, we get 26.93. So to determine if there are any outliers, we're going to say the minimum, the quartile 1 minus the minimum. If quartile 1 minus the minimum is greater than 26.93, then there is an outlier. If quartile 1 minus the minimum is less than 26.93, there is not an outlier. Same token will apply to the other end of it. So we're going to look at the maximum minus quartile 3. If that's greater than 26.93, then we have an outlier. If the maximum minus 26.93 is less than the maximum minus quartile 3 is less than 26.93, then we don't have an outlier. So looking at our data, which again I don't have on the screen in front of you, but you have in your notes there, the minimum, I'm going to write up here, was a negative 38.32, and the maximum was 36.29. So let's start with the maximum. The maximum of 36.29 minus quartile 3, which was 20.76, is, got to get my handy dandy calculator, is 15.53. And since this is less than 26.93, then we can assume that there are no outliers on this end. Outliers. There are no outliers on the right end. Okay. But let's look at the left side of the box plot. So quartile 1 was 2.81. minus a negative 38.32. So make sure that you remember two negatives like that would make a positive. So 2.81 minus a negative 38.32 gives me 41.13. Let me rewrite that. I didn't write that very clearly. 41.13. And since 41.13 is greater than 26.93, we know that there are outliers on this end. Okay, so now that we know on the left end there are outliers, now we need to go look at that data and determine what those outliers are. So if you're looking at your data, and again, I'm looking at page 72 of the textbook, or if you've printed out the PowerPoints and you've got those there you're looking at, or maybe you are looking at the spreadsheet, we're working in the growth data right there, so you've got the data in front of you. Remember that the quartile 1 fell between observations 2 and 3, right? So we're going to first look at the difference between quartile 1 and observation 2. So quartile 1 minus observation 2 is quartile 1, remember, was 2.81 minus observation 2 was 1.71. So that difference is clearly within the range of 26.3. That's just a 1.1 difference. So observation 2 is not the outlier. But if I look at quartile 1 minus observation 1, now we have 2.81 minus that negative 38.32. Now we can see that since that is the 41.13, observation 1 is the outlier. So again, since 41.13 is the outlier, and we could check, it's possible to have more than one outlier. That's why we checked observation 2 as well. Observation 2 was good because it was in that 26.93, the interquartile range times 1.5. But the 38.32 is considered the outlier. So now when I look at my box plot, notice I've got my whiskers are drawn from the quartile 1 down to the minimum, the quartile 3 up to the maximum. But notice my minimum is this is observation 2, because this is what we're saying our minimum really kind of almost should be, and this observation down here is the outlier. It's too far away from the interquartile range, so it's considered an outlier. Now, that doesn't mean it's not real data. It really did, maybe it really did happen, right? That was a bad year. I'm assuming that, again, I'm recording this in July of 2020. We're in the middle of the corona pandemic. There's probably going to be a lot of outliers when people look back and are looking at data from 2020. They might say, well, that's an outlier. We may want to exclude it because we don't want to draw conclusions based on hopefully just this 1 year of data. So it doesn't necessarily mean it didn't happen, but it means that it's so far out of the norm that I may want to think about anyway, excluding it and not drawing conclusions based on that outlier data.